Um, so hi, everyone. My name's Ethan. I was the project manager for our project, which was TuTraffic.
My name is Isaac. I was the Scrum Master for our project.
My name is McGuire. I worked on the front end and a little bit of the database.
My name is Logan. I did some with the machine learning and a lot of documentation.
My name is Brian. I did a bit of the front end for mobile and desktop.
My name is Adam. I worked on integration testing and DevOps.
My name is Raymond. I worked on the front end and the database connection.
And my name is Jason. I also worked on the front end.
Sweet. So TuTraffic is a application that aims to make parking for Temple students and people who live around Temple easier. And the way we do this is with our Raspberry Pi setup. They each have a camera and they would be set up over a parking lot. Typically, we would aim it outside a real parking lot, but we don't have 10 cars to play with. So we made a little model to show what it would work like. It does this, detects all the available spots and then sends it off to our front end app. Let's get started with the demo.
All right, so I am currently circling the Circ building because I have a class to get to. And since I am nearby, let me use the current location. And look at that, a bunch of parking that's near me. So I'll have an easy time finding spots, and also I didn't have to type in my address, so no texting and driving. The meter icons are for street parking, and the little car icons are for lot or garage parking. Now I cannot parallel park, so I will be switching it to just lot parking. I'll go to my user profile and select lot or garage. Then I'm going to go back to the map. And now there's no street parking. It's only lot parking. And I'm going to click on this one right here. Look at that, CircLock. It has 8 spots. Great. And I'm going to navigate to that. And if I was actually going, I could just, it takes me to Google Maps and I could just click start. Automatically go. All right, and now I have a lot of classes in Circ, so I'm going to favorite this spot, click on browse, click add to favorites, success. Check my favorites, and there it is. And I can use this whenever I want to. It's automatically saved and quick and easy if I want to check the status or directions. After class, my friend is going to come over to my place at the View, and they're worried about parking. So I told them about TuTraffic. Let's see how they're doing.
All right, so I'm going to visit my friend in Philly later. I'm a bit nervous because I heard Philly drivers can be a little aggressive. So she recommended me TuTraffic. So I'm going to type in her address in the search bar. So 1110 West Montgomery. Search. All right, great. There looks like there's some spots around. I'm trying to save some money because I might be here for a few hours. So I want to not have to pay per hour. So I'm going to go to user profile and I'm going to make sure I'm selected only free parking. So let's go back to the map and all these spots should be free. All right, this one looks good. Let's click. So this is on Warnock Street, and that is currently being represented by our display over here. So all the data that I'm getting on my screen is from this thing. So I'm gonna get ready and I'm gonna let this sit because it live updates. So hopefully when it's time to go, there'll still be enough spots so I can come here. Oh, and look at that. I just got a notification on the bottom right that said there are less than 5 spots available. And I have a little bit of a commute to Philly. So I don't think these spots are going to be here when I get there. So I'm just going to pick a spot with a little more and navigate there. And then I should be all good. So this app is really helpful. I wonder how they set it up to get it all working.
Okay, so I am an IT person working for Temple who has set up this system on our lots. We have the camera aimed at the parking lot we want to work on it, so now I can run our little setup program to get it started. So it will display an image of the parking lot to ensure that you're facing the right way. So I can go here and verify that this is the image, and then I can now crop and select only the parts of the parking lot that we want to be looking at for detection. And then now it asks me if it's a lot or street. I can lot. It'll ask us for the name. This is Dirk. And then how many spaces we think we can fit. Just for demonstrations, I will say 10. And now it will start capturing a set of 30 images. That way we can average them out to remove any moving cars, so they're not counted in our parking lot spaces. Once it averages out the 30 images, it will then run our open source image detection called YOLO through OpenCV. There we go. It says there are 9 spots available. And if we go onto our website, you see the search now has 9 spots. So it is sending that information to Firebase, and then our website is updating with that information live.
So this was our demo for TuTraffic. We saw that our application works on the spot target and we like favorite spot, and we also saw how the backends work and how it will detect moving cars and with people taking up spots. If you want to try the application, it's currently up right now, and if you're here in person, you can probably move the cars around to see what's happening. But thank you all for coming.
Are there any questions so far? Anybody want to play with the cars? Anyone want to see what I want to do? Deliberately put this at the end to play with the car. The only, yeah.
How hard was, I don't know who worked on the image detection stuff, but how hard was it? And what were the challenges that came with it?
So we essentially had 2 different setups. We had our free parking and we had a lot parking. The machine learning algorithm we use was essentially stop. If you look up YOLO V3, it is an object detection and it will detect tons of different things. We had issues with it detecting our miniature streets as like handbags. So, you know, it detected a bunch of different things, but we just narrowed it down to like cars and traffic buses. And so that in and of itself was like pretty plug and play. The initial setup was a little weird. We hadn't had very much experience with machine learning before. And when it came to the parking lots, it really wasn't too difficult to get it up and running because the user themselves could set what the maximum amount of spots was. So you take your picture of your parking lot, you can say like, oh, the maximum amount that it fit in here would be 40. So then it detects 30 cars and it outputs that there's 10 cars on it. That was quite easy. When it came to the street parking, IVIC was doing that. It was a lot more difficult because there's no reference frame we could rely on. You know, we don't know how far away the camera is going to be. We don't know how big the cars are relative to the camera. So we can't kind of decide how big a spot is from that. If my understanding is correct, essentially how it was working was we would take one of the cars that we did detect in the image and then just like move it over and find a new spot and move it over, find a new spot. Any spot that was filled up would be detected. Not sure if that's exactly right.
Yeah, pretty much. It's slightly changed for the end where it was basically, it would take the information of the cars on the screen and would use that to kind of get an idea of how many spots could be on in that area of the street and then would take that average car dimension and roll it across the screen. And if that bounding box corresponded with the bounding box for a car over a certain interval, I think it was like 90%, then we would consider that spot taken. And if there weren't spots, or if there was no detection, it would consider that a free available lane.
Yeah, so did our best with this. It's certainly not perfect. Neither was this. Especially with the toy cars, we noticed like with the stock images that we were getting and like doing our initial testing with, it was working really well at detecting cars. Then we take it out to the real world, like pointing it outside the window, there's a tree in the way. The lighting isn't the same all the time. So we were having difficulties with this, and the model isn't obviously trained on toy cars, it's trained on real cars. So we had some issues with that, but the machine learning really wasn't too bad. Because it would take, I feel like it would be a lot harder to make it equally better, you know, like the next step up would be a lot harder, but it wasn't too bad for this.
What was the final delay time of, between the machine over here recognizing the cars and updating the server?
Yeah, so I think with it running on the pies, it was about 9 to 12 seconds for each detection, depending on the size of the image, which is a lot of why we let you drop it down with what important information is. When it was running on our computer, like I know on my laptop, it would take like 2 seconds to run. So it's not that heavy of an algorithm. And our initial idea was that we wouldn't have to have this like a backend server running, but if we were to do it again, I think that would be a better option, just to send the pictures off and have it run on a better computer than on the rinky dink little Raspberry Pi. But it's not too slow. Our interval of updating would be about every 20 seconds. So as long as it was below that, we're fine with that.
Something you said earlier had to do with the question I had, which is like, how realistic would it be to implement something like this on Temple's campus? Like, do you think you'd have to put like a lot more work into it to get it production ready in that way? I know you're mentioning it, like issues like lighting and trees and real people using it would kind of mess up. Like, did you have an idea of where it could go from here so that it could be implemented like that, or can you speak on that?
Yeah, I think that it would take a lot of work to get it like production ready for that. It's like pretty good, but I don't think we could really be prepared for all the edge cases that we've come up with. But like, what if there's traffic and like all the cars are stopped in the middle of the road? Like right now, we average out all the pictures, so any car that's consistently moving isn't going to get picked up by the algorithm. But if we if people were just stopped in the middle of the road, like they shouldn't do it really, we have trouble with that. So I think it would take a lot of work to we could do it, but it would definitely be at least another downhill process.
What were your favorite parts of the project? I like what, this is gonna be like a Blair Witch project at the end, but like, what was your favorite contribution to the project or favorite thing that you did?
Personally, I really just loved, like, I never really worked with machine learning before. I tried a couple of times, like nothing was working. And for this project, with the help of Isaac and Loaded specifically, it was just like we managed to get it working within like a week. It was like, oh wow, this like that was so nice. It was the rest that was hard. But that was what I enjoyed the most.
I guess it's the same for me. I think Isaac will probably say the same. They were more in depth with it than I was, but I don't know, machine learning is such a hot topic right now. So there were a lot more resources than I thought there would be. So it was really nice to learn something new and relevant.
Put it on the list.
Yes.
Saw there was, I stomped over questions from here.
Yeah,
It's all somebody.
you're talking about like the billing things, or reminding me like I feel like people use like traffic cones, like trash cans to save a parking spot. Is that something you could detect?
Well, the YOLO algorithm is technically like an object detector, so we could spend more time and like incorporate those. Essentially, it would just be like, it would be more difficult with the parking lot, I think, for that, but with street, you could just have it count like any object it detects in the way as part of that. So if it's blocked by any object, it would be available, but then you would get issues with just like all the raining traffic in the street.
I have a weird one, and again, probably another Capstone project, but, it occurs to me, you were talking about the street parking, where the camera, obviously, there's an angle of attack with the camera, where the further away, the harder it's going to be to determine what the size of the space is available.
Yeah.
And what jumped into my head instantaneously was, what about overhead drones?
Is that we were getting like the best results on in our initial testing, were those like nice overhead shots, and also the very clear like side shots, anything from like same level. I mean, obviously you can't see the bars.
Right.
So that would be nice, like maybe we can implement that, like having it on light poles facing exactly down. We also use a lot of the rain.
I was just thinking for the practicality. Initially, I have to say, when I first heard this project, I was like, why? Now I see the project and I'm feeling like I want this now.
Yeah.
And I think there's like a serious need for this, and then that's what got me thinking of the drone idea, where you could set it up so that the drones fly. There's like, this is say it's simple.
Yeah.
And like the campus would be quite willing to pay for that to support it, you know, it would make the business model. Yes, I'm a bit business model. Let's just say then they absorb the cost and they get the approval to fly drones, but there's a whole issue. Let's just say we can make that happen. Would it be possible within the context of the model to be able to determine, based on your fly time and the number of drones that you have, and be able to track that, be able to organize and know where those spaces are? Less of an issue with the parking lot, obviously, with free parking, it would be more ideal, and you would lose the issue of having to negotiate the space on a light pole or a breakfast. I don't know, it just struck me that when I called it and I saw that actually work, that there's a real possibility there, I think. But I don't know, but you know, my experience with them, obviously, what you guys did is like, that's so good.
I think that is a really interesting idea. It would be good for street parking, especially if you could like line all the images to one really long image.
That's like the issue of trees and over coverage and things like that.
Liability issues.
That's like saying, I think there are 2 people have to die from like.
Several car crash.
It's funny that you did mention drones for doing this. When I was first researching how to do this kind of lot and street detection, one of the papers I found was doing overhead parking lot detection with drones.
It's happening.
It's funny, it didn't even occur to me, drones, so I don't know what I'm like.
Well, I don't know what the work on that is, somebody else already thought of it.
No,
I'm still behind.
Yeah. I feel like we got Ethan's perspective on like favorite parts of the project. How about the rest of the group? What were your favorite things of working on this? What would you recommend to work with in the future?
Well, I did a lot of stuff with user settings, so having it be that they can change from street to lot and stuff like that. And it was just really fun when everything was working, when things would work from both the machine learning end, so like we would actually know how many spots were there, but also when I would have it be street and it actually would only show street parking.
Yeah, working on the testing, I wasn't sure if everything was gonna work together, so it's a nice surprise to me that like the test would pass, and it was mostly errors with my test logic rather than the project itself, like all the tests were passing, which is
Glad to hear this testing. That's good. Okay. Yeah. Yeah, oh, Jay, yeah.
For the like YOLO algorithm for the object detection, is that the first like, have you guys explored other like algorithms? Going that one?
I did the research on that.
There were a couple other options that were kind of more complicated and you would have to, they weren't trained, you'd have to go in and train them with your own images. And we found that just using a pre-trained car detection image model worked way faster.
Really don't have all those.
I was curious, who worked on the Raspberry Pi piece of the project, and can you speak on that a bit? I'm curious, I've never used it before, and I know like we're talking about brainstorming capstone projects at the beginning of the year and like looking at that. I know you were saying like, oh, probably use a better like back end server and everything, but can you speak on your experience working with Raspberry Pi?
It was me and Isaac working together on that mainly, because we each had one of us home working on it. For me, to be honest, I found it there's like so many little things. I could not get the camera working for the good majority of the semester for reasons that are still unknown to me. I feel like Isaac had a bit of a different experience.
I too found it pretty annoying. There were a lot of like small weird things you have to tweak to get it to work properly. And then also the fact that since it's the Raspberry Pi, it's just a lot slower. So you'll develop the code on your main computer and then it'll be instant. And then you go over to the Raspberry Pi and you have to wait and you're still waiting. And oh, now you see it's wrong. And then you have to go back and start changing it. Some of the other issues we kind of had with the Pis were the cameras they're depreciated now. They don't technically have support anymore. They have legacy support. So trying to get those to work was a real hassle. But I think overall, using a Raspberry Pi to kind of enhance your project is a really fun way to do it. And you can do a lot of, I just wouldn't recommend doing a car detection camera.
You have a lot of control over the environment, like going from trying to detect like and like the actual outdoors to like having this that we play with a lot, and we can actually control it, the lighting, because you know it would work great in here and we point it out the window and the image is pure white. We have no control over exposure or any of the actual camera settings on it. It's just like take an image. That wasn't great, but they're really fun to work with. Because it's just like a smaller computer, but
Would you recommend it as a capstone project, or is it kind of the same, just like, yeah, like as a supplement, but don't base the project around it?
I think it's good as a like embedded programming project. So it's like if that's something you're trying to get into, like obviously it's a great experience because it's like the Pis are, while they're like a little finicky, they're also incredibly user friendly for one of these types of computers. So it's like a great intro to that. I would recommend it for a captain project.
Yeah, I was gonna ask, so because it sounds like most of it is, like most of the frustration hinged on software. So how much Linux experience do you think a student that would take on a project like this needs? I feel like I know the answer, but yeah.
It's like a mini Linux that you get with it. So I wouldn't start this project if you had to be like, how do I make a directory? How do I see into a new direction? Like that probably should be your first thing that you have to learn if you're trying to use these. It should. I would say come in with some base knowledge, but if you're doing it at Temple, you get that.
Yeah.
So you mentioned that you guys both have the Raspberry Pi. Do you have like any like parking lots set up in your like room?
This was pretty recent. Up until then, we had just like playing it outside of our house. Hang on to but this was just to get some extra control that was better.
I not really go on a tangent, but I heard about like you guys were interested in machine learning and it should be part of the project and so on and so forth. We do offer machine learning 4,000 level courses, but in the past semester, the enrollment has been low relatively than what's the opinion by very
Yeah, I know I applied for machine learning class last semester and it required Cal 3, which most people don't take.
Oh, that's true.
On my end, I was a double major. I had outside, I just did not have the room, credits wise.
Oh, that was me too. I'm CS math. I just had no room. I wanted to
Yeah.
take it so bad. I just couldn't.
So room means, cannot be the schedule.
I actually, for me, it wasn't necessarily a credit issue. It was like a scheduling issue because I was in both departments and like everything that was required just like overlapped. I didn't have room for extra electives.
I was trying to, I remember I was thinking about this like 3 semesters ago, and then I was just doing it in my head. I'm like, oh, I have to take Cal 3, and I'm trying to get this in with all the rest of my stuff, and I just like, I need to graduate first. That's first priority.
So if we can relax the Cal 3 requirement, that will help.
Yeah.
Yeah. There's not many other classes that you need Cal 3 for, in the CS like track, at least that I know of. Like there's like 2 or 3 other ones. So if because like machine learning is so popular, and it's like something industry to get into now, that would be great. So like, or if there was the Cal 3 class version, the version I didn't need it.
I took machine learning last semester. I would argue that I use probability statistics and concepts from calculus 2 and a little bit in calculus. Yeah, very beginning, like doubling that was about. But I saw that probably. Okay, all right.
You got your answer.